In this video, I will introduce you to the basic trigonometric functions sine, cosine, and tangent. Here are the definitions of sine, cosine, and tangent. First of all, these only apply to right triangles. So the first thing you need to know is a right triangle is a triangle that has a 90-degree angle in it, and the side that is across from the 90-degree angle is the hypotenuse. So you're going to need to know where the hypotenuse is. The little box of the right angle is always pointing, the corner of the box is always pointing right at the hypotenuse. Now, if you pick one of the acute angles of the right triangle, like let's say this one right here, across from the angle is the opposite side. Right next to the angle is called the adjacent side. So once you have the hypotenuse, the opposite side, and the adjacent side labeled, it's time to define sine, cosine, and tangent. Because sine of the angle is the opposite side divided by the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You can use this silly acronym to help you remember. You can say SOHCAHTOA, and that one silly word reminds you of the definition because the SO part of SOHCAHTOA reminds you that sine is opposite over hypotenuse. The CA part, cosine, is adjacent over hypotenuse, and the TOA part, tangent, is opposite over adjacent. So put it all together, and SOHCAHTOA reminds you of these three definitions. Let's see how this works in practice. Look at problem number 1. Find each value. Give your answers as reduced fractions. For part A, we are supposed to find the sine of angle D. So we're focusing on angle D. Well, first of all, the hypotenuse is the hypotenuse no matter what angle you're looking at. So here's the 90-degree angle. That makes this the hypotenuse. Now, we've circled angle D. Across from angle D will be the opposite leg. And then the other leg is the adjacent leg. By the way, I'm using this word leg all of a sudden. You've got the hypotenuse. The other two sides are called legs. So every right triangle has a hypotenuse and two legs. So now that we've labeled opposite, adjacent, and hypotenuse, we can jump in. So remember that sine is opposite over hypotenuse. So that's going to be 28 over 53 in this particular case. Now we want to find the cosine of angle D. Remember that cosine is adjacent over hypotenuse. So that's going to be 45 over 53. And finally, we want tangent of angle D. And tangent is opposite over adjacent. So that's going to be 28 over 45. Now let's switch gears and focus on angle E. So I'm going to go ahead and circle angle E now. 53 is still the hypotenuse. It is still across from the 90-degree angle. But if I draw an arrow going away from angle E, that will point at the opposite leg. The other side is the adjacent leg. So once again, I have opposite, adjacent, and hypotenuse. Remember that the sine function is opposite over hypotenuse. So that will be 45 over 53. Cosine of angle E. Cosine is adjacent over hypotenuse, so that will be 28 over 53. And then tangent is opposite over adjacent, so that will be 45 over 28. So that's how you find sine, cosine, and tangent. Let's practice that some more. This time we want to find the tangent of angle L. So let's do all of the L's first. That way we can go ahead and circle angle L. Let's start with the hypotenuse, which will always be across from the 90-degree angle. So the 61 is the hypotenuse. If you draw an arrow pointing away from the angle that you circled, then you're looking at the opposite leg. And then the other leg is the adjacent leg. Adjacent means right next to. So tangent is opposite over adjacent. So in this case, that will be 60 over 11. And then sine of angle L. Well, sine is opposite over hypotenuse. So that will be 60 over 61. And then cosine of angle L. Remember that cosine is adjacent over hypotenuse. So that will be 11 over 61. All right, so that is sine, cosine, and tangent of angle L. The next three problems involve angle K. So let's go ahead and circle angle K. The 61 is still the hypotenuse. That did not change. The hypotenuse is always across from the 90-degree angle. But if I draw an arrow going away from angle K, that arrow is pointing at the opposite side. Opposite means across from. And then the other side is going to be the adjacent side. Whoops, I forgot the A. Adjacent side. Adjacent means right next to. So here we go. Tangent is opposite over adjacent. So that's going to be 11 over 60. Sine is opposite over hypotenuse. So that's going to be 11 over 61. And cosine is adjacent over hypotenuse. So that will be 60 over 61. Yes, it's just that easy. So for problem number 3, we need to find each value. Give your answers as reduced fractions. Okay, so on the other 3 problems, well, the previous 2 problems, we were given all 3 sides of the triangle, 28, 45, 53, 11, 60, 61. Suddenly, here, it looks like we are not being given all of the information. We only have 2 sides. We are not given the third side. So what's up with that? Well, don't forget about our old friend, the Pythagorean Theorem. That was the one that went a squared plus b squared is equal to c squared, where the c squared, the c part, was always the hypotenuse. So basically, this is c right here. We can use this to find the hypotenuse that's missing. So here we go. We'll do 10 squared plus 24 squared is equal to c squared. Obviously, 10 squared is 100, but 24 squared, not so sure. So 24 squared, that's 576, and that is equal to c squared. Well, 100 plus 576, that's going to be 676 is equal to c squared. If you want to get c by itself, you need to take the square root of both sides. So what is the square root of 676? So that's 26. So we found the missing side. So don't worry if you ever are given only 2 sides of the right triangle. You can easily find the third side using the Pythagorean theorem. Now we can go ahead and do what we were doing before. Let's do all of the problems involving angle R first. Now, let's see. The 26 is the hypotenuse because that is across from the 90-degree angle. But if we are going to focus on angle R, I think we should circle angle R so we can draw an arrow going away from it, and that arrow will point at the opposite side. The other side is the adjacent side. Okay, so cosine is adjacent over hypotenuse. So that'll be 10 over 26. But this reduces, if we divide by 2, that's going to give us 5 over 13. Tangent is opposite over adjacent. So that'll be 24 over 10. We have to reduce, so this will be 12 over 5. And then sine is opposite over hypotenuse. So in this case, we have 24 over 26. Whoops. So that'll be 12 over 13. How about angle T? So let's start over. This 26 is still the hypotenuse, guys. It is across from the 90-degree angle. Now that we are focusing on angle T, let's circle angle T and draw an arrow going away from it. That arrow will point at the opposite side. The other side is the adjacent side. So one more time, cosine is adjacent over hypotenuse. So that will be 24 over 26, which reduces to 12 over 13. Tangent. Tangent is opposite over adjacent, which in this case will be 10 over 24, which reduces to 5 over 12. And then sine is opposite over hypotenuse. In this case, that's 10 over 26, which reduces down to 5 over 13. Problem number 4. Label two sides of this triangle to show that tangent of D is equal to 3 over 4. Well, we're mentioning tangent. So please remember that tangent is opposite over adjacent. So that means that the 3 has to be opposite and the 4 is going to be adjacent. Also, notice that we are talking about the tangent of angle D. So let's circle angle D. Start with the hypotenuse, which is always across from the 90-degree angle. So that means that this is the hypotenuse right here. Now, if I draw an arrow going away from angle D, that is going to be the opposite side. The other side will be the adjacent side. So I have opposite, adjacent, and hypotenuse. We are supposed to label the triangle so that the tangent of angle D is 3 over 4. But that means that the opposite side has to be 3 and the adjacent side has to be 4. So that's why we're going to put a 3 on this side and we're going to put a 4 on this side. The word adjacent is kind of in my way. So I'm just going to slide that down a little bit. All right, so I'll put the 4 right here. So there we have it. Tangent of angle D is 3 over 4. That's opposite over adjacent. And that's exactly what we have here. If we focus on angle D, the opposite side is 3 and the adjacent side is 4. Now, use the Pythagorean theorem to find and label the length of the third side of triangle DEF. So we're going to use the Pythagorean theorem to find the hypotenuse. And remember how the Pythagorean theorem is a squared plus b squared equals c squared, where the c is always the hypotenuse. So that means we can do 3 squared plus 4 squared is equal to c squared. All right, that's going to be my hypotenuse. And this is 9 plus 16 is equal to c squared. And then that is 25 is equal to c squared. And to get c by itself, we need to take the square root of both sides. And the square root of 25 is 5. So we get that c is equal to 5. And that was the hypotenuse, guys. So I'm just going to slide this hypotenuse label over a bit to leave room for the 5. Now, use your label diagram to find the other trig values, reduced fractions. So they have already filled in the tangent, opposite over adjacent, 3 over 4, just like we wanted. But what about the sine of angle D? Remember, sine is opposite over hypotenuse. So that will be 3 over 5. What about cosine of angle D? Cosine is adjacent over hypotenuse. So that'll be 4 over 5. Now we have to switch to angle E. The next 3 parts are all about angle E. So I am not going to erase those numbers because I worked very hard to get them. All right, I'm going to leave those numbers in place. All I'm going to do is I'm going to now circle angle E because we are talking about the sine, cosine, and tangent of angle E. So you have to pick the correct angle so that you can draw this arrow, which tells you that this side is now the opposite side. And this, the 3 is now the adjacent side, which is the opposite of what it was a moment ago. So it all depends on which angle you're looking at. So now I can go on and say the sine of angle E, we know that sine is opposite over hypotenuse. So that'll be 4 over 5. Cosine is adjacent over hypotenuse. So that'll be 3 over 5. And then tangent. Tangent is opposite over adjacent. So 4 over 3. Let's practice this one more time for problem number 5. Label the sides of this triangle to show that cosine of angle P is 40 over 41. Well, cosine is adjacent over hypotenuse. That means that the 40 has to be adjacent, and the 41 has to be the hypotenuse. We're talking about the cosine of angle P, so let's circle angle P, and let's draw an arrow going away from angle P. That arrow will indicate the opposite side. So this is the opposite side. The hypotenuse is always across from the 90-degree angle. So this right here is definitely the hypotenuse. And that just leaves this side over here as the adjacent side. So let's fill in the two numbers that we are given. 40 is the adjacent side, so this side is 40. And then 41 is the hypotenuse. So we have 41 right here. Use the Pythagorean theorem to find and label the length of the third side of triangle PQR. All right, so we're going to be finding this side over here. You know what? I'm just going to call it x for right now. So our Pythagorean theorem, we're always saying a squared plus b squared equals c squared. And a common mistake is to automatically put the unknown in the position of c. But that is a mistake. The c part, the number over here by itself, is always the hypotenuse. So the c squared has to be 41 squared. So this x is going to be, it doesn't matter whether it's a or b, but it's going to be one of those. So I'm just going to erase this and just do what I said. So we are going to have x squared plus 40 squared is equal to 41 squared. So again, when you do the Pythagorean theorem, make sure that your hypotenuse is always the number that's by itself. Okay, so x squared plus, well, 40 squared is going to be 1,600. Okay, and then 41 squared is going to be 1,681. Interesting. So if I want to find x, I first must subtract 1,600 from both sides. And that's going to leave me with x squared is equal to 81. Then we take the square root of both sides to get x by itself. And of course, we will get x equals 9. Square root of 81 is 9. So that was our opposite side. So let's go ahead and I'm just going to erase the x and put 9. Now that we have all three sides, opposite, adjacent, and hypotenuse, we should be able to do all of these trig functions. So the sine function is opposite over hypotenuse. So that will be 9 over 41. All right, they already filled in the cosine function because we were given that from the start. So let's move on to the tangent function. Tangent is opposite over adjacent. So that will be 9 over 40. And then the remaining problems involve angle Q. So we are going to have to change these labels up a bit. So I'm going to now circle angle Q. So here's angle Q. If you draw an arrow pointing away from angle Q, you're pointing to the opposite side. So this 40 is now opposite. That means the 9 is adjacent, which makes sense because adjacent means right next to, and the 9 is right next to angle Q. The hypotenuse does not change. So the sine is opposite over hypotenuse. So that will be 40 over 41. Cosine is adjacent over hypotenuse. So that is 9 over 41. And tangent is opposite over adjacent, which is 40 over 9. So that is a nice little introduction to the trig functions of sine, cosine, and tangent.